So first, Alibaba shared a paper about how they built embeddings for candidate retrieval. So these embeddings, they use user behavior and they prepare the logs. So from the user behavior, they can build a graph of the item. So if a user browses a sequence of items, they can use the relationship between each item and build a bidirectional graph. And then once you have a bidirectional graph connecting all the items together, they do random walks on the items on this graph. And this random walks is just going to randomly start from a point on the item and then randomly walk on it based on the probability of each item leading to each item. And this is based on the similarity between the item, right, which is the edge strength on the graph. And then this random walks is going to give you a sequence of items. Then they use extended TensorFlow, which is their version of TensorFlow, to do graph embedding training. All this is really just word to vec. So with this sequence of items, we are able to train word to vec. We're going to able to represent each item with a vector. And then they do inner product search for every item. So for every item in the catalog, they do inner product search or cosine similarity if you prefer. And they find the top 1,000, the top 100 most similar items. And this goes into the eye-to-eye similarity map. This is our approximate nearest index. And this is the section. So given the sequence of items, we train our embeddings, and this is our embedding model. And then our eye-to-eye similarity map is our approximate nearest neighbors index. And then in the online environment, this is how it happens. A user comes in, they send a request. This request goes to the Taobao personalization platform, which then given this user, and maybe this user has previously browsed these 3 items and previously bought these 2 items. Okay, now we have 5 items. Go to the approximate nearest neighbors index, and for each item, find 100 closest nearest neighbors. So this 100 closest nearest neighbors is going to return as the candidate set to the Taobao personalization platform, which then sends it to the ranking prediction ranking service platform. And this is the ranker. So given this candidate sets, rank them. And the ranking prediction platform is going to return the ranked list to Taobao personalization platform. And that's how the recommendations show up on the homepage. So you can see over here, they distinguish between the offline and the online environment. So this can maybe run once a day, once a week, depending on your budget cost. But it does not have to be available 24/7, right? However, the online aspects of it, this has to be available 27. And for this, you have on-call with high severity, something fails, but this is okay. This is not too critical. Let's look at another example, also from Alibaba, for ranking, where they build a graph network. So again, this is the offline system, where they use their external knowledge and item profiles to build a graph, and then they augment it with user behaviors to build a better graph, and then they use user profiles. And these user profiles are then combined for instances to train an adaptive graph network. So this is the graph, the data that they're using, and this is the ranker that they're training. So ATBRN is their final ranker. Then in the online approach, and this diagram isn't drawn very well where they show how the online is done, but basically this ATBRN here is used in here, right, in the real-time prediction. In the online approach, when a user comes, hey, given the user ID and some of their historical items that they have interacted with, generate a bunch of candidates. And this bunch of candidates is going to go to the real-time prediction platform, which then gets the user ID, goes into the graph, and then does the prediction. So this is candidate retrieval that we see here. And as is coming here, so with the candidates, you can see that they're using the feature stores, the item profiles, and the user profiles to augment the data, and then they rank it. And of course, at the end, there's the recommendation results, and they log it, whether the user clicks on it or not. And of course, these logs are then used for in the offline prediction system as well, for their to train the candidate retrieval models as well as their ranker.